Hey everyone, welcome to lesson 3.4, Finding Zeros. In this lesson, we're going to learn how to find the zeros of a quadratic, and we're going to learn what in the world zeros are. But the two methods we're going to focus on today are graphing and square rooting. And you'll notice that things look a little different in today's lesson because what's going to happen is I'm going to do the notes within your assignment. So if you scroll through, you can see how many slides there are. But you'll also see that some of them say notes at the top, like this. Okay, so like this one says notes at the top, but it's the exact same thing as these two, because these two are your assignment. This one is the one we're doing together. And then if you keep scrolling, you'll see another section. This section is just like these two. There are some parts of the notes that I won't end up asking you to do in the homework, for instance, these two, because they are just setting you up to be able to do the rest of the problems, kind of like we normally would do in notes. So you have the option to take notes digitally and do your assignment digitally. You will also have the option always to go over to your notes, which you have printed out for you already, and or I will always share a printable version of the notes if you guys would like to print them at home. Okay? So I will have a link for you guys on this assignment on Google Classroom, which you can print or just use to write it down if you would like, both for the notes and for the assignment, because everybody likes something different. So, the x-intercepts of quadratic functions are called the zeros because they are found by setting the equation equal to 0. And you can kind of see what they are here. There are a couple of options. Most parabolas are going to have what we call two real zeros, where it crosses twice on the x-axis, which makes sense because it makes a U, so it should cross twice. But there's also some that only have one real repeated zero. What that means is it kind of counts as two on its own, like this, because it both goes down to that point and turns around back up at that point. So it kind of counts as two. And we'll explain more what that means when we talk about polynomials in the next unit. And then the third graph, notice how it's too high. It doesn't actually ever cross the x-axis. So it is possible for a quadratic to never cross. It can have 2, 1, or basically no zeros. Okay, real zeros are the ones you can see. This one still technically has solutions, but they're called imaginary because we can't see them on the graph. So, there are a bunch of methods to finding these. Today we're going to talk about graphing and square rooting, but you could also use factoring or something called the quadratic formula, and then last but not least is completing the square. Okay, and we may or may not do this one depending on timing and whether or not we are still virtual. So let's jump right into it. If you want to find the zeros of a quadratic function by graphing, then you want to make the graph, guys. So this -5 on the inside means I'm going to the right 5 from 0, 0. So I'm going to come to the right 5. And then it also means that I'm going down 9. So I'm going to go down 9. And I may end up relining this up. We will see. There we go. So right 5, down 9. And then it has no number in front of my parentheses, so that means I'm going to go up 1 over 1. And I may not have enough points for this, so I may end up making a copy. Up 4 over 2. Okay, and I do need to make a copy of these points, so what I'm going to do is show you how, because you may need to do this in the future too. I'm going to highlight that point, and then I'm going to hit Control-C, Control-V. And that makes a copy of that point that I can then drag up 9 over 3. And copy that point. And instead of over 3 that way, I'm going to go over 3 this way. Okay. So my two spots where it crosses the x-axis are at 2 and 8. So I'm going to come down here to zeros and say 2 and 8. I'll make this look a little better for you guys. 2 and 8. Okay. And then I'm going to do the same thing over here, except for this time there is a 2 in front, and there's a plus 4 on the inside. That means I'm going to go to the left 4, and the minus 8 means I'm going down 8. Okay? And normally my pattern would go like this one, up 1, over 1. Since there's a 2, that means I'm doubling the up part, so I'm going to go up 2 over 1, like that. And then next, I would normally go up 4 over 2, because 2 squared is 4. I'm doubling the up part only, so instead of going up 4, I'm going to go up 8 over 2. So you're pretty much graphing it just like we did before. And then I am going to show you one last thing. If you guys want to, you can come up here to this line tool and select a line that goes up the middle. If you hold the shift key, it'll make it perfectly straight, by the way. And then you can make it dashed if you want to see the axis of symmetry, so you know how to go 2 and 2. Okay, and actually I'll probably add one off to the side if you guys want to do that, so that way you don't have to make it on your own. Okay, and then coming over here, oh sorry, I forgot to finish this one. -6 and -2. There we go. And then over here, the +3 means I'm going left 3. The -5 means I'm going down 5. And then this one goes negative. So notice how it's going down. It's going to go down 1, right 1. And down 1, left 1. And I'm actually going to stop there, guys, because you can kind of tell my graph is going this way. The x-axis is up here. So there are actually no zeros to this one. And I just wanted to show you guys what that would look like. So you're really kind of imagining the parabola that goes through the points you put on there. If that bothers you, then what you can do is come up here to the line tool and pick scribble. And you can try and draw a curve through these points if you're having trouble visioning it. Like that. Okay, so you can kind of see my parabola now. And then what you're going to do is I'm going to skip to the next section. My suggestion would be to go try a couple of these graphs and pause the video and then come back. One last thing before I move on to square rooting is this is easiest to do when the function is in vertex form and when it nicely fits on a graph. We will talk about other methods that don't look like this to start with. And so that's when you want to use this one. You'll use square root method when it can still look like vertex form, like this, but these numbers wouldn't fit on the graph. 36 isn't on the graph. Neither is 18. Or if it's already multiplied out like this. Okay? So this only works if you can use the vertex and the pattern the way we graphed it in 3.1. Now, for square rooting, what you're going to do is get the thing being squared by itself. Okay, so if it's x in parentheses squared, that's fine. It might just be x squared, though, without the parentheses. Then you're going to square root both sides because the only way to get rid of squared is to square root. You're going to write your answers as a plus and a minus because the square root of 25, for instance, is 5 and -5. Okay, and then if there's any solving left to do, you'll do it then. So kind of like we did with absolute values, these are going to split into a positive and a negative. And then we are going to simplify non-perfect square roots because the square root of a times b could also be the square root of a times the square root of b. Sorry, that got a little messed up. No, you can't change it. We're going to split up the inside number into multiplication by finding the biggest perfect square that's a factor, so that we can actually take the square root of something. We want the smallest number possible left inside. Okay? Before I go on and do this, here are a couple of key things you can do on the Chromebook. If you hit Control period, you can type an exponent. That's what makes it go a little small up top. Or you can use Control 6 to type the little caret button. Either one of those is fine. And then we're just going to type SQRT for square root, since you can't type one of these bad boys. Okay? And then if you would like to, you can type 2 dashes or minus signs and then an inequality arrow facing to the right. This is also also near the period, except for it's shift. And then that will make it into an arrow for you. And I'll show you what that looks like or how you could use that. So there should be a place where you guys can type right here. What you're going to do is type the square root and then parentheses. We're going to turn 108 into a multiplication problem. And I want to try and find the biggest number I can to divide 108 by that's a perfect square. So like 108 divided by 4 is a perfect square, which works because I don't get a decimal, but other things go into 27, telling me that I should probably have picked a bigger number. So I'm going to go ahead and try 9. 9 works, but again, 12 still has other numbers left. What we want left underneath is like a 2 or 3, something that doesn't have any other numbers that go into it. Oops, sorry, hitting the news button. Go back. And then 3 squared is 9, 4 squared is 16. So I'm going to try 16 next. That doesn't go in nicely. 5 squared is 25. Oops, not 125. And 6 squared is 36. There we go. 36 times 3 is 108. So just try dividing by perfect squares. And if you're not sure, then just Google perfect squares list and use that. Okay. Let's see. Images. This isn't a bad one because it's really easy to read. So 4, 9, 16, 25, 36, 49, 64, 81, etc. Okay, so I'm going to come back over my notes, and I'm going to type 36 times 3. And then I'm going to use the arrow thing. So I'm typing 2 dashes and then shift period. That turns it into an arrow for me. And the reason why I'm doing that is because all I'm changing is I'm splitting this up into 2 square roots. So the square root of 36 times 3 is the same thing as the square root of 36 times the square root of 3. You can split that square root up. And then the square root of 36 is 6. It doesn't need the square root anymore because we already did it. So it's 6 square roots of 3. And then I'm going to come over here and do the same thing. So square root of, and I'm going to try dividing 48 by 4, 9, 16, 25. So 48 divided by 4, make sure I type it right, is 12. But again, other numbers go into 12, so I'm going to keep going. 9 doesn't work, it's a decimal. 16, 3. So I end up with 3 and 16. It's not always going to be 3, that's just a coincidence. Okay, and then we would split that up into square root of 16 times square root of 3. And no, you don't need to type all of this work for me. If you already know what it's going to end up being, you don't have to type anymore. Okay, so I'm going to type 4 square root of 3. And that's it. The reason why I'm talking about these first is because you might have to do that as you're solving some of these. So over here, what you're going to do is get this x squared all by itself. So if we were solving the equation 3x minus 75, we would add 75 to both sides, which would give us this. 0 plus 75 is 75. Okay, so I'm adding this 75 over to this side, like that. And then I'm going to divide by 3 on both sides, which is going to give me just x squared. And then 75 divided by 3 is 25. And then I want to square root both sides. I'm going to type that over here just so you guys know what I'm doing. The square root of x is x, or x squared is x, and the square root of 25 is 5. You also have an answer of x equals negative 5 because when you cancel out a squared, it could have been 5 or negative 5 because 5 squared is 25 and negative 5 squared is 25. And then I'm going to do the same thing down here, 5x squared. I'm adding the 120 to the other side. So it pretty much just changes to the opposite and stays over here. And then I'm going to divide by 5. And again, I'm using my control period to get this little 2 up there. Okay, that's this part right here. Okay. And then I get x squared equals 40, and I need to square root both sides. But when I do the square root of 40, I need to simplify it. Because the square root of 40 isn't a nice number. So I want to change that to the square root of two things that multiply to 40 that aren't, one of which is a perfect square. So 40 divided by 4, 10. 10 doesn't have very many other things that go into it, and neither of them are perfect squares. So that's actually my answer right there, 4 times 10. So x is going to be the square root of 4, which is 2, square root of 10. So the number that doesn't have a square root has to stay inside the square root. Like up here it was 3, but the 36 became a 6 because it did have a square root, and then you didn't need the square root part anymore. And it will equal negative 2, square root of 10. Don't forget that everything is going to be a positive answer and a negative answer. Coming over here, I'm going to type x minus 4, control period 2, equals 36, because I'm adding this 36 to the other side, and then I'm taking the square root of both sides. So I get x minus 4 equals 6, and x minus 4 equals negative 6. Right? So the second you take that square root, you need a positive and a negative, just like I did up here. The difference is you still have to add 4 to both sides here. So you're going to have two separate answers that aren't the same number. So 6 plus 4 is going to be 10. And negative 6 plus 4 is going to be negative 2. And that's where I'm going to stop there. Actually, I'll type over here really quick. I'm going to do this one really quickly. I'm going to add the 18 to the other side. Then I'm going to divide by 2. And then the square root of 9 is 3. So I get x plus 3 equals 3. And x plus 3 equals negative 3. Now I need to subtract the 3 from both sides. Either x equals 0 or x equals negative 6.